Hello, everyone. I hope you're all safe and well. My name is Danesh-Mand, and it's my pleasure delivering this short presentation to you today. As you're probably aware, to further support the students undertaking the subject of Advanced Project Risk Management 15317, a number of additional online training material have been developed. These short targeted presentations will help you to better identify and understand the key aspect of this topic for further studies. However, I would like to highlight that please note that this material should be only used as a supplementary, not a replacement for full training documents and references provided for this subject. So please refer to the university's course online platform or contact your lecturer to access and discuss the full set of training material for this subject. On that introduction, let's start on our session today with the subject of schedule contingency determination. A quick outline of a number of sessions that currently they're available, the short videos. We have a couple of case studies for QRA, quantitative risk analysis. There is a session for risk and contingency management overall in terms of the process. The program today, the presentation today is for schedule contingency determination, and there are 3 more sessions available as well. One for cost contingency calculation or determination, contingency allocation, and contingency control. A quick introduction about myself. I'm currently a director with KPMG Australia, looking after project risk management, mainly working on the major infrastructure projects during the development phase and delivery. Civil engineer. I'm civil engineer from background, and I did a master in hydraulic and design, but I never became a designer. I went to the site and worked with the tier 1 contractors mainly. I think it was about 20 years ago that 20 years ago that I decided to spend a bit more time on the risk side, and then I got my second master in project controls and construction management, and application of risk assessment and risk engineering in delivering major projects. And I'm spending a lot of my time over the last 15 years trying to help the clients to use the risk engineering in practice. I'm currently a New South Wales president of Risk Engineering Society, or RES. RES is one of the technical associations under Engineers Australia, and we are trying to promote the application, the education and application of risk engineering for engineering first for engineers, but also the wider construction and project delivery or project management. Before I start the conversation today, I would like to highlight that the views and discussions and the comments and recommendations that we will and I will express today are those of myself, my personal experience, and do not reflect or represent the official policy position or recommendation of KPMG Australia, Engineers Australia, or Risk Engineering Society. Obviously, they do have a general nature and should not be used for any decision making without further assessment. So on that basis, let's get into the topic today. Before I get into the schedule contingency determination, I would like to share with you just a couple of very briefly where the concept is coming from. So when you look at the ISO 31000, which is the 2018, which is the standard for risk management, the ISO standard for risk management, and that's a document that we mainly refer in terms of risk management in Australia. The standard is putting the risk management into some sort of 3 pillars. One is the framework, which you see the leadership and commitment, and it's going through the development of the design, implementation, evaluation, improvement, and integration. The second pillar is related to the principles, and is all about how we can create value and protect the value out of the risk management. And the last part, or last but not the least part, is the risk management process. And if you haven't done the risk management course yet, or the topic, my suggestion is that I strongly recommend that you do risk management first before you get into the contingency management. However, if you look at the risk management, there are a number of steps from creating the context or establishing the context to the risk assessment part, which is the identification. You need to identify the risk, we need to do the analysis, and we need to evaluate, we need to treat them, and concurrently, obviously, we need to monitor it, review it, communicate it, and report it as well. The connection with the contingency is sitting on the risk treatment. Why? Because if you do after the risk assessment and after you consider all those treatments, if the residual risk, which is the risk after the treatment, is still not acceptable and further treatment is not visible. So for example, it doesn't make sense to spend more money because it's not worth it, right? For those scenarios, you might need a contingency, which might be time and or cost. And that's the concept of contingency, and how does it link to the bigger picture of risk management. When it comes to, if you haven't done the contingency management, I suggest that you read the other session or watch the other session for contingency management, and make sure that you read the full material. But this is the second part, which is how do we do the schedule contingency, and how do we calculate that? So, but just before that, if you want to formally define the contingency is the specific allocation of resources. It might be cost, it might be resources, or it might be time required in addition to the baseline estimate or base estimate or base schedule to cover for the risk. The other element that is quite important is that you notice that there is an element of desired confidence level. And that's quite fundamental, because depending on the level of confidence level that you're targeting, the contingency might go higher or down. It's at the end of the day, there is no one single solution. There is no one single answer to this problem. You want to be more confident, you need more contingency. The challenge is, and as we discussed in the contingency session, the problem is you ask for too much money. That's good if you win the job, but the problem is you don't win the job if you're a contractor, or if you're working with the government, your project may not go ahead. So that's the challenging part of it, because you need to make sure that you ask for optimum or reasonable money that you can win the job or push the project ahead, and then you can deliver it successfully. A couple of notes that I would like to highlight before I continue. Contingency is not a replacement for project cost estimation, for a proper cost estimation. You need to have a proper cost estimation. Contingency is the next step. Contingency shouldn't be included in the base estimate, in the budget, cost plan, or forecast. We do see a lot of cases that the people, when they're putting the estimate together, they embed some contingencies into the base estimate or base schedule. By the time the team gets to the contingency assessment, they put another layer of that on top of the previous one. And again, it's not the optimum way. If you do have some undesirable event that is highly likely to happen, the recommendation is that, and when I say highly likely, means, for example, anything more than 80% likelihood of happening, you better actually, the recommendation is that you better take it out from the base estimate and base schedule, and you better take it from the contingency calculation and put it as part of the base estimate and base schedule. And the last but not the least is that the contingency shouldn't and doesn't include escalation, which is how the prices will change over the time. In terms of the overall process, by referring to this document that's in the next slide, I will introduce it a bit more. It's a risk contingency guideline, and that's a document that RIS started to develop from 2013. The second edition of the document was released in 2019, and that's quite it's a very good document. And I'm not saying that because I'm with Rez. It's it's a document that a lot of people actually contributed to that, and it's a good starting point, and it will give you a good understanding of different aspects of the of this concept. And then it's a good starting point that you can help you to go through that journey. In terms of the contingency management, the way it works, I mean, and that's the document that I was talking about, the contingency guideline, the second edition. And the key elements of the topic, as you can see, there is a process, there is a determination, allocation, and controls. There is a development and delivery. Going through the project life cycle is important. Contingency at different levels of project program portfolio, contingency and project performance, excuse me, and government requirements in Australia. These are the different topics that they're applicable. The topic for today is for schedule, which is a contingency determination for schedule. In terms of contingency, the other element of which is quite important is that before you think about the schedule contingency, you need to make sure that the schedule that you develop is representing the most likely scenario. In other words, you follow some of the rules and techniques, making sure that the base schedule is a proper schedule. And generally, if you don't do that, so there are two scenarios: you develop it yourself, or you're given a schedule and then someone is asking you to do the schedule risk analysis. If you're developing the schedule yourself, there are some recommendations that there are some references that you need to refer, like PMI scheduling standard, or a couple of other good standards that can help you to develop a schedule properly. If you're given a schedule to do the schedule risk analysis, then there is a process in place that you need to go through it, and you need to, generally we have schedule health check through 3 steps of checking contractually, checking the integrity of the schedule, how good logically, and so on and so on, and in terms of the structure as well. So there are 3 elements, but we will get into that shortly. But if you're developing a schedule yourself, one of the good documents that can be used is a PMI practice standard for scheduling. The second edition is 2011 one. And the number of elements that you see how the process works. And in terms of starting the project, in terms of defining the methodology, in terms of the tools that you want to use, some of the data that you're using to develop it, and eventually the model and updating and statusing, which is not important at this stage because unless you're in the delivery phase. But in terms of some of the inputs that you use, generally the most common inputs for scheduling are some of the templates that you do have, some of the quantities, resources, how many resources, the productivity rate is quite important, the work and scope statement, the construction logic, other assumptions like how many working days, is there any restriction on the hours, all those different assumptions that you put. And eventually the question is, with all those assumptions and uncertainties, what's the confidence level associated with the schedule? How do you do that? So these are the inputs, and there are some variables for each those inputs. The other part of the challenge is the methodology. And the methodology is if you have developed the schedule yourself, most likely you have used the critical path analysis or critical path method, or CPM, which is some sort of logic-based scheduling method, right? But there are a wide range of different methodologies that the industry be using them. Like the CPM is one of the deterministic one, but there is also critical chain. There are a number of other ones, but there are some stochastic techniques as well, or probably some sort of range like pairs, like PNET, like Monte Carlo simulation. In addition to those logic-based scheduling methods, there are some sort of repetitive scheduling methods, or like the line of balance, which is quite common for linear projects like high-rise building or tunnels or road or rail, which is different with the methodology of the critical path. So again, you see how the tool, the method that you use for your project and business requirements is quite important even before you start to have a conversation about the schedule risk assessment. And the subject of today is not, so we are not getting into the scheduling part, but I just wanted to highlight to you that these are the key elements of the picture that should be assessed or should be decided and will have a huge impact on the schedule risk assessment, and you need to be aware of them. And the last but not the least, when you have the inputs, when you had the methods of scheduling, the developing a model, you ended up having the output. And the outputs generally, there are over four areas or four outcomes. The schedule by itself, there might be a model data, there might be a baseline. When you're comfortable with it, you play with it, and eventually you're comfortable with it. And there are some resource requirements. If you have allocation to the resources, you can actually get the resource histograms, you can discuss the over allocation, under allocation, and so on and so on. So it's part of the management side of it. And then the remaining, the key question at the end of it is that with all those uncertainties associated with the schedule, what's the confidence level? In other words, how confident are you that we can finish this project within this timeline? You're making some assumptions on the logic, you're making assumptions on the productivity rate, you're making assumptions on the number of resources, you haven't done the resource allocation, blah, 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 blah. Altogether, are you confident enough that we can finish the project on time? And what's the confidence level? And that's the time that's a question that schedule contingency calculation or determination can answer. So in other words, can give you the result for that. So when you look at the determination or calculation by referring to the RES guideline, there are a number of, they're sitting on the deterministic and probabilistic. And it can be as easy as predefined factor based, which is based on the percentage on the base schedule, up to the schedule risk analysis, which is the simulation for SRA. I'm not going through the details for those methodologies, but please refer to the full document or the RES guidelines for the detail and some of the examples that you can refer for them. But in terms of the schedule risk analysis, there are four steps that, there are key steps that you can go through them, and it's going from left to right. It's if you're given a schedule and you need to develop an SRA, you need to make sure that you develop, you go through the schedule health check and rectification. And rectification, as I said earlier, the health check, generally we recommend that you do it through 3 steps. First, the contractual requirements, understanding what needs to be done, and then you check the integrity of the schedule, and eventually is the structure of schedule. And there are some requirements. As I said, please refer to the guideline, and guideline will provide you with the quite detailed steps of this process. After you're comfortable and rectify the problems, then you need to allocate the risk into the schedule, and it might be through the inherent and contingent. There's a number of ways, like the 3-point people put the durations or uncertainties against the activities, and also put the contingent risk into it, or some of the methodologies like risk factor. So there are a number of different ways that you can allocate the risk into the schedule. Then you run it through the Monte Carlo simulation. Again, the same. If you haven't used the Monte Carlo simulation, please refer to the other session or other training material. That Monte Carlo will go through the number of iterations and will pick a different assumptions and run the model for you. And eventually there are some outputs that will give you the result. So let's have a look at example. So this is the input, the model that we had for one of our projects. And it's, you see it's a software that we have been used, and different schedules has been gone through the model, and then the outputs, the different software that you can use or we use in industry for generating it. It's generally there is a histogram, there is some sort of giving a range of the dates and the likelihood, different scenarios. This is for scenario analysis. that you make some changes and you run it again and you see how does impact it. Then the last two that you see here in the bottom is just related to the schedule health check. So there are a number of platforms that can help you to run the schedule and making sure that the schedule actually does have a good quality before you run the SRA. And I think that's about it for today. Again, make sure that you refer to the full training material. And if you have any questions, please keep in touch. I'm also on LinkedIn if you would like to keep in touch. And also we do have a group online on LinkedIn. You're more than welcome to join. So that's about it. So till the next time, good luck and thank you. Bye.